This evening I'm cutting an 1¼ BSP taper thread in this component here that's going to be a pipe flange for that air tank. I don't have a tap, so I'm having to screw cut it. And being a tapered thread, that presents challenges. There's many different approaches for screw cutting taper threads, but this is my preferred approach. Certainly not claiming glory for this. I was taught it by somebody ages ago, can't remember their name. I have the screw cutting tool upside down in a boring bar facing the operator. Being a right-handed thread, this clearly means that the chuck has to rotate in reverse. I've got my taper turning attachment set up so that as the carriage moves away from the chuck, the tool moves towards the operator, therefore this end is the widest part of the thread. Obviously I'm doing it that way because I can then trial my fittings in there to see if I've reached the correct depth. By moving in this direction, it means I have the spindle running in reverse. So as well as doing a tapered thread, it's also running backwards. That might seem dubious, but I find it by far the easiest and safest method to work. The big advantage of doing it this way is that once you've put your cut on or return the tool to the starting position, the moment the carriage moves away from the chuck, the backlash is in your favour. It's pulling the tool further into the cut as it would during normal screw cutting, rather than the backlash allowing the tool to move away from the cut, with all the issues of dealing with backlash which is present on almost all of these age of lathes. I have the compound slide set at half the included angle and I'm using the slide to put the cuts on. This merely returns to 0 each time, which aids my repeatability and saves me making a mistake, which hopefully won't be on this video. I've even got a stop set up so the boring bar stops shy of fouling the inside of these jaws. I never ever have mechanical stops when I'm screw cutting, because if you hit them you damage things, but because the tool will be moving away from the stop rather than towards it, it's perfectly safe to have a stop. Must apologise that I don't seem to find a tripod position that's going to suit this task, so it's going to be freehand. If anything, that shows how risk-free this method is. Start the spindle in reverse. Move the cross slide back to my 0, which is 0 every time, which makes it nice and easy. I put a cut on using the compound slide. I'm against the stop, so it's quite happy. And we can see that the lead screw is going to move the carriage to a position of safety away from the chuck. Wait for my dial to come round. I'm engaging on 3 and 1. The tool moves away from the chuck and out of the workpiece, removing a lovely sliver of swarf. Back the tool off. This thing was very funny looking at it through a camera angle. Return the tool to the start position with the aid of my mechanical stop, so I've got no worries about hurting anything. Back to my 0, placing on the next cut on the compound slide. Looking for 1 and 3, this dial is shiny chrome plated and I can't stand it. 3. And another cut. I'm quite happy with how I've ground that tool. So I have a handy thread gauge in the form of this completely blunt tap that wouldn't cut butter, which might be useful one day, and look at that, suddenly it is. I'm going to call that okay. Only thing that's going to go in there is some malleable iron galvanised pipe. The great advantage of using this setup is all about the backlash. On many lathes, you'll lose a couple of inches of travel of the carriage before the taper turning starts to do its thing, and by running with the spindle in reverse, tool upside down and moving away from the chuck, you eliminate that issue with the backlash, and you attain a far greater degree of safety than you would with the conventional method of working towards the chuck while screw cutting. Thanks for tuning in.